Hello. In this tutorial, I thought we would look at how to calculate variances and covariances using Excel, both from the computational formulas and also with the built-in functions in Excel. So a small little toy data set, artificial data, hours of study, and self-efficacy. So we've got 15 people. So person one, we could even type it in here. Person one gives us studies for 150 hours and their self-efficacy score is 56. Again, all made up data. We'll use this first tutorial to calculate the variances and covariances, and then in a subsequent one we'll look at slopes and regression lines. So here's the raw data. An easy function in Excel is to just calculate the sum, and it's very straightforward. It's just sum and highlight the numbers you want to sum, and voila, you've got it. Hold on. Okay, it's good to see mistakes too. So we can go on and calculate the mean. Straightforward, it would be very easy just to say 2498 divided by 15, the number of scores we have, 166.53. I think that leaves open a lot of possibility for typos, so I like to use the built-in Excel functions. So you could also just say equals. All equations begin with an equals. Click on the cell. So we click on the 2,498, divide it by, and the n, 15, same number. Or maybe easiest of all, we could say equals and use a built-in function in Excel. So the second one is average, and we could just average these numbers right there. Highlight, click enter, we have it. Again, with the variance, we can use a built-in function in Excel. We could also do it by hand, and I'll show you by hand in a second. But we could calculate the variance. And notice there's lots of different variance formulas here. We want the variance of the sample, not the population. So the sample variance, and we highlight the numbers we want to use and click OK. Standard deviation, again, you can use a built-in function, which is just standard deviation, again, of the sample, and highlight and scroll. Or clearly, it's good just as a little double check, a little reminder that you understand. You can think about, well, what's the relationship between the variance and the standard deviation? Well, the square root of the variance is the standard deviation. So you could go square root that, enter, and happily you get the same answer. So here we have hours of study. We've got the sum and the mean, variance, standard deviation. We could do all those same calculations over here, but Excel is really good at transferring formulas. So we could just highlight that whole area, click over here, Control V, and voila, we've got the sum, the mean, the variance, the standard deviation. What happens when you do that is just look up here. Let's pop over here. Here's hours, the sum of the hours of study, and we just summed it, B2 through B16. Excel uses logic, and it says, well, you summed B2 through 16 here, you've clicked in this cell, then let's just sum D2 through 16 here. So we have all of that. Now, to go ahead and actually use these conceptual formulas, I think is important, because when we just type in a function in Excel, it's like a miracle occurred, magic happened, but I think it's important to see what's happening. So if we look at the variance of x, that would be also written as sigma squared x. We can see we're going to subtract each score, x, minus the mean of x, and we're going to square that difference, and we're going to sum that. So it's going to sound like the sum of squared. So it's the sum of squared differences of each score around the mean, and then we'll divide by n minus 1. So again, we start off formulas with an equals. So we say equals 150. You could also type it in, but it transfers more easily if you just click on the cell. Minus, and go to the mean. Here we are. Enter. And there we've got it. So we could just copy that down, but we actually want to make sure that we subtract the data point from the mean each time. So to fix this cell, to make sure that we're always subtracting the mean, then we would go up here to the bar, formula bar, and type in a $sign. I have no idea why they use a $sign. So it says always column B, and this says freezes always 19, always cell 19. So we have that frozen in there, fixed in there. We can copy it and paste. So then you can just double check that here's B3 minus, again, we always want 19. So we've done that. Now, a couple things here. This is the plane deviations. Typically, we want to square these for most things, certainly for the variances. What happens? What does this sum to if we don't, as is, what does this sum to? Stop, think about it. These are deviations around the mean. Well, it sums to something not horribly useful for us in many circumstances. It sums to 0 because these are deviations around the mean. Okay, well, let's keep that for now and see how we'll fix that. And then let's go ahead now and do the same thing here. So we're going to say equals 56 minus the mean of self-efficacy. And we'll go here. I'm going faster than I would go in class, but I figure you can run it back. But just you have to promise me never to make me listen to myself. That's not fun. So we've got the deviation. We Control C. Here, Control V. And we've got the simple deviations. I'm going to broaden this out a little bit. And I always double check. I double check a lot to make sure I haven't made a mistake. So we have the sum, and we could sum all of these, and sure enough, it sums to 0. So then let's work through this now. We want to get the variance of x. So really what we need to do is square this deviation. So in Excel we can add a column. Let me just show you again. I right-clicked on that, and it says insert, and voila, you insert a column. So I'm going to just call this hours study dev squared, and we could take each entry. If you want to square something, you could use the uppercase of the 6, that little caret, squared, and you've got that squared. Control C, we copy it down. Control V. Look at all those. Gosh, look at all those numbers. Clearly, we don't want to have not particularly meaningful. That just looks kind of wacky, doesn't it? So we can reduce the decimal to something that looks less nutty. Excel will use all of the points past the decimal, but this is just a little more easy to view visually. And go make sure we've got this down. I always check 1 or 2 just to make sure it's doing what I want. And then again, let's go over here. We've got self-efficacy. We've got the deviation. Let's right-click, insert, and let's call this self-F deviation squared. And this is more clearly you could do this in many fewer columns. I'm spreading this out so that you can see all the different pieces to it. So we've got, we'll square these deviations. Uppercase 6, get the little hat squared, and you have it. And we copy and paste on down. Control V. And we get all the crazy numbers. And let's reduce those decimals. So you can can adjust the column lengths. I mean, some of these look a little bit big, but you can, oops, look at that. I like things to look fairly neat. It helps me to think about it better. Whoops, that's kind of nutty too. So we can reduce all of that down a little bit. We've got the deviations, we've got Y, and you know, just to keep track of these, why don't we just change the color of the font? Indulge me while I change colors here. It's a little, whoops, oh, there we go. And we could put that with a different background. So we make that kind of a, I don't know, what would be pretty? Now I'm getting a little silly. Okay, so we've got hours of study, we've got self-efficacy, and let's do a different background color. I mean, just to make it a little clear. And we've got this cross products thing here, which we'll worry about in a second. We won't worry about it, we'll work with it. So let's first take a look then at the formula for X. We want the hour study deviation squared, and we're going to divide by n minus 1. So the top is the sum of squares. So we can go ahead and sum that column right like this, 179.3, and then to get the variance, we'll just divide that number, the 1749.3, the sum of squares, divided by n minus 1, which is 15 minus 1. And we've got the 124.98, which is nice because it matches over here. But this we did conceptually. Also make sure that you're looking and matching with the printout. It's very easy to get a little typo buried in here and miss it. So let's do the same thing here. So we've got the square deviations. Let's sum them. And so these are the sum of the square deviations. And then we can go ahead and divide by n minus 1. And we've got the 82.92, which matches, which is fantastic. So we've got calculated the sum of squares for X. We've got the sum of squares for Y. We've got the variances, the variance of X. We have the variance of Y. And now this cross product. So let's just take a look. We squared this because we could have expanded this equation and had x minus x bar times x minus x bar. Clearly, it's a squared value. Here it was just easier to square it. Here we're saying the deviation of x minus the mean of x times y minus the mean of y over x minus 1, n minus 1, excuse me. So it's easy, really easy to make an error here in pulling cells. So it's worthwhile to slow down and be really careful. We want to have just this deviation, not the square deviation, just the deviation. So that would be this one, squared times, and that is the little asterisk, so it's shift uppercase 8 times the self-efficacy deviation, 116, control C, then we scroll down, control V, let's get the sum. So this is the sum of the cross products. And then while these are variances, this, because it's the same variable with itself, this is covariance. So we get the covariance the same way. Let me scoosh this so you can see. So this is the sum of the cross products in the top, right here. And we're going to divide by n minus 1, and we get the covariance. So n minus 1, and we get the covariance between the two. So in this little tutorial, I've shown you how to calculate variances, covariances with the built-in functions in Excel, as well as with the the conceptual formulas, which I think are important to think about, you know, as you're starting out and working. Just want to get a pretty color to go with that. Okay. In the next tutorial then, we'll go ahead and we'll use this data and we'll calculate correlation, slopes, regression lines, intercepts, and move on from there. So thanks, and keep me posted on if these are helpful.